So this is actually a kuan class, a preparatory subject no for your design subject sa higher years sa civil engineering, since here ato nang ipang consider ang properties sa ato ang materials. So it is important no nga to consider that one because sa ato ang pag-design daghan ta og factors nga gina-consider, and isa na ni ato ang properties sa materials nato no, and the stresses and deflections no nga mag-occur sa ato ang structures. So there are different types of loadings and results in different types of stress. So first we have the axial force. Axial force is denoted as letter P. So this component measures the pulling or pushing action perpendicular to this section. So a pull represents a tensile force that tends to elongate the member, and a push is a compressive force that tends to shorten the member. So ang kaning axial force class no, ang iyang keyword lang yun ano is ang perpendicular to the section. So when we say axial force, then ang ato ang gina-consider ana nga force is katong force that is perpendicular yun sa section, no? So in contrast to that, we have also the shear force, or this is not letter T but rather the Greek alphabet no, katong tau. If you're familiar with Greek alphabet tau, muna siya ang representation ni shear force, but sometimes shear force can be designated as letter V. So don't be confused by that no sa ilahang representation or designation. So these components are the total resistance to sliding the portion to one side of the section past the other. So shear force ang ihapong keyword ani class is parallel force pod ang ato ang gina-consider no. So if sa atong axial force perpendicular nga force ang atong i-consider, then sa shear force parallel pod nga force ang i-consider nimo no sa imuhang section. So let's say for example, you have section letter A sa figure. I hope makita ninyo no. So sa axial force perpendicular ana nga section, and sa shear force ang force nimo is parallel na sa section no nga cross section letter A. For a while kay nauntay auto admit no dinhi sa Google Meet. Anyway, so the third and the fourth we have bending moments and torsion no or torque. So bending moments are components measured the components rather no components measure the resistance to bending about an axis. It is merely denoted as letter M. So you're familiar with moment naman, di ba? Sa ato ang statics of rigid bodies. So bending. So when we say bending, if nakay beam no or nakay figure or object or body, then if that is subject to bending moments, iya ra nang ginabend no from the term bend. So inana lang ang iyahang gina-resist nga bending action. And then sa torsion, this component measures the resistance no, the resistance to twisting the member. So if bending is like this, ang torsion pod is iya pong gina-twist no. Mura tani ga vlog. Dili mag-focus. So, iya pong gina-twist ang member. So, inana pod ang ilahang convention no, ni bending and ni torsion. So, torsion or torque is commonly designated as letter T. So, mo tong gi-emphasize na ko earlier that shear force no is not designated as letter T, since most likely torsion na ano or torque ang ato ang pag-ila kang letter T. So again, shear force is tau na siya nga representation, or to avoid confusion pwede pod letter V na lang inyong gamiton no sa pag-designate ni shear force. So simple stress. So simple stress, or also known as the normal stress, it is defined as the force per unit area. So stress as a whole, or stress, is defined as a force per unit area. That's why ang formula ni stress is um, force divide by area, no, or P over A. So stress is designated by sigma, Greek alphabet hapon, no? Greek letter rather, Greek letter sigma. So muna ang designation ni stress or iyahang representation, where P is the applied load and A is the cross-sectional area. So when we say normal stress is actual force lang na siya class. So actual na force ang imong i-consider, which means that if mag-compute ka og normal stress, then ang imo i-consider nga area should be perpendicular sa imuhang force, no? So dapat perpendicular sa imuhang force ang imuhang i-consider nga area. So naapod tayo ginatawag nga shear force. So when we say shear force or shear stress rather, kung mag-compute po tawag shear stress, ang imo pong i-consider ana nga area is parallel sa imuhang force, no? So again, definitions nato no from sa atong introduction, no? Si shear force is parallel siya nga force no sa imuhang cross-sectional area, and si axial force or axial force is perpendicular siya to this section. So pag normal force or normal stress rather, if normal stress, then perpendicular nga area, I mean perpendicular force nga imuhang i-consider no sa imong cross-sectional area. But if shear stress pod, then ang katong parallel area sa imuhang force ang imong i-consider. But for today, we will focus more on normal stress, no? So next meeting siguro or next week, ayan na ta mag-discuss sa ato ang shear stress no, and bearing stress. So for today, purely normal stress lang sa ato ang i-discuss. So we have also units for stress, no? That are units units for stress are the units of force divided by the units of area. So we have SI units or the International Standard System of Units. For force, it is measured in Newton, and in terms of area, it is measured in square meter, and ang ato ang unit no for stress is since it is a unit of force divided by the unit of area. Therefore, atong stress is Newton per meter squared, which is just equal to Pascal. Since Pascal is equal to Newton per meter squared. So 1 Pascal is equal to 1 Newton per meter squared. So the primary unit of stress is actually Pascal. Then that is for SI units, no? Then for US customary units, force is measured in pounds, and area is measured in inches squared, and then stress is in PSI, no? So PSI is equal to 1 pound per inch squared. So muna iha definition on ni PSI. So pound per inch squared. Munang pasabot ni PSI. We also have conversions, no? Like for conversion lang, 1 kip. So a kip, by the way, means kilo pound, no? So from the term kilo pound, so 1,000 pound, no? So 1 kip is equal to 1,000 pound. Therefore, 1 KSI is equal to 1,000 PSI. So ana lang ang ilahang kuan class. Um, Conversion no ni US customary units or kanito ang mga system of units. So ma-encounter na to ni sila no as the class progress. So we will be solving SI units and US customary units nga system kay para pod nga versatile mo no sa ato ang system of units. So whatever unit nga ihatag sa inyo so kabalo mo kung saan pag-solve. And familiar mo no with PSI, KSI, Pascal, and etc. Okay, so let's have sample problem number 1 for our discussion today, which is about normal stress. No? So a composite bar consists of aluminum section rigidly fastened between a bronze section and a steel section as shown in the figure. Axial loads are applied at the position indicated. So determine the stress in each position. No? So we have axial loads no acting on our a bar, no? A composite bar rather, no? So we have bronze, aluminum, and steel. And I indicated nga actual loads nga applied, no? Specifically sa ilahang positions or sa ilahang asa nga points. So for a while ha, ato sang transfer sa ato ang virtual whiteboard. Excuse me. Ay, wala pa di ay nakuan. So ayaw lang siguro i-access ang link, no? Okay. Let me just copy the problem para mas easier sa ato ano. Okay. So again, ako lang i-discuss na or balikan ang concept ni normal stress. So let's say you have a box and I force, no, na nag-act sa iya ha. Then, if we say normal stress, so ang imo i-consider ana nga area is again perpendicular sa force which is kani siya, no? But if mingon ka og shear stress, so parallel sa imong force. So asa man ang parallel sa imong force, pwede ni siya or kani siya, no? So depende na siya kung asa siya nga direction or asa ang asa gi indicate sa problem, no? Then we have the formula for our stress, the general formula, no, for our stress. Katong sigma is equal to P over A. So ako lang po siyang i-copy. So that's it. Okay. So we have sample problem number 1. Natay composite bar consists of aluminum, bronze, and steel nga sections. And we are asked to determine the stress, no, in each points. So ato ipang determine ang stress, no, at each section, no, or at each point. So ato i-determine ang stress kang bronze, aluminum, and kang steel. So and to do that, ato san i-cut ang plano or let's analyze first si bronze. Okay. So mas easier if mag-copy paste lang ko copy paste lang ito sa figure para dali ang pag-draw. Okay. So for bronze and if i-analyze nato first ang left part sa ato ang cutting plane, no, or ang left na section sa ato ang cutting plane, then ang ato ang force lang nga i-consider is 4,000 pounds. And if mag-cut ang plane, then ma-display no ang iyang internal reaction or ang iyang internal force. So in this case, to maintain static equilibrium, then ang ato ang internal force kang bronze is just equal to, ako na lang siya i-name as PBR, no? Internal force at bronze is equal to 4,000 pounds lang gihapon. So that is just actually summation of forces no on x-axis, and since si 4,000 laman ang force nga nag-act, so iya lang siya gi-resist no or gi-equate. So action reaction. So if na-determine na nato ang to ang internal force for bronze, then makompute na nato iyahang normal stress no, since stress is equal to, so normal stress of bronze is equal to PBR over the cross-sectional area of your bronze. So we have internal reaction is 4,000, and area of bronze is given 1.2 inches squared, no? 1.2 inches squared. Therefore, normal stress for bronze is equal to, pila man ni siya? You have 4,000 divided by 1.2. So 3,333.33 no PSI. So pounds per inch squared. So that is PSI. So if gusto mo siya i-express no as KSI, so you can have it no at 3.3 KSI. So ana lang. Okay. So now let us analyze aluminum, no? So oops. Okay. So si aluminum na pod. So for aluminum, mag-cut yapon ta og plane no kang aluminum. So consider lang yapon ako ang left side sa ato ang cutting plane. Oops. So 4,000 pounds. And na po siya ay actual load no sa connection ni bronze and aluminum, which is 9,000 pounds. Okay. So if nagkatag plane, ma-display na ato ang internal reaction. So assuming going to the left ang reaction no ni internal reaction ni aluminum. So that is PAL lang no. Actually kuan lang na siya class. Summation of forces on x-axis equal to 0. So ako lang i-separate sa sa equation no ang left side o ang or going to the left or going to the right. So PAL plus 4,000. So both are going to the left. equal to 9,000 since si 9,000 naman ang going to the right, no? Therefore, you have PAL equal to, so 9,000 minus 4,000, you have 5,000 pounds. So, napasabot na ang internal reaction ni aluminum is 5,000 pounds. So, we can now compute for the stress, no, at aluminum. So, the stress at aluminum is just equal to PAL, which is 5,000, divided by the cross-sectional area of aluminum, which is, pila to siya? 1.8 inches squared. So, the stress at aluminum is equal to, pila man yun siya, be? 5,000 divided by 1.8, 2,777.78 PSI. So, ayaw yun mo kalimot sa units class. So, part yun na siya sa inyong solution no, and sa inyong answer. So, if wala unit, so, ayun na, adi na siya correct yun. So, na-determine na nato atong stress no at aluminum. So, next, na tayo stress kang bronze and kang aluminum. So, last na lang no, si steel na lang. Since ang question lang man is determine the stress to in each position. So, for steel, much easier if atong i-analyze if magkataog plane kang steel is ang right side no sa iyahang section since isa lang ka force ang atong i-consider which is si 7,000 pounds. Okay. So ako na lang siyang gi-copy na para dali ra ang pag-drawing. Okay. So um for the internal force rather no internal force or reaction at steel, so equal lang siya kang 7,000 pounds no. So mo na to ang internal reaction at steel. So we'll designate it we'll designate it as PST. Then to determine the stress at steel, it's just the internal force, 7,000, divided by the cross-sectional area of steel, which is pila to 1.6. 1.6 no? 1.6. Therefore, you have the normal stress at steel equal to 4,375 PSI. Okay? So, this would be our answers, no? Sa to ang sample problem number 1. So, stress at for bronze is 3,333.33 PSI. For aluminum, 2,777.78 PSI. And for steel is 4,375 PSI. So wala mo ng if wala mo na curious, no? Actually, puwede pod nga mag-analyze ta or mag-start ta sa toang analysis is sa right side, no? So sa ako ang solution today, nag-start ko sa analysis is sa left side, no, sa system. But puwede pod ka mag-start diri kang steel. Then, puwede pod nga pagkuha nato sa stress, no, kang steel or
Excuse
internal
me.
reaction at steel. Yes?
Pwede mi mag-ask sir kanang about aning concern ba sa aluminum side bitaw sir, 'di ba na
Mm,
ay 9,000 pounds. What about
yes.
kaning 20 ay 2,000 pounds lang?
Okay. So, um, again, if mag-analyze ta og cutting plane, so mamili ka, no, kung left side or right side. So in this case, sa atong aluminum, cut nato siya and left side ang ato ang gi-analyze. So kato lang pong forces, no, nga makita nimo sa left side sa imuhang cutting plane ang imuhang i-consider. Since wala man na apart ang 2,000 pounds sa imuhang analysis or sa imuhang consideration sa imuhang cutting plane, so dili na siya ma-include. However, if you choose to analyze the right side, no, of your cutting plane, so kani siya, then ma-include si 2,000 pounds, no, and si 7,000 pounds nga force since ang imong i-analyze is kani siya as a whole na siya.
Okay sir, get sir.
Mm.
Thank you sir.
Sir,
But
kanin.
anyway, regardless, the same lang yapon ang makam-am nato ang answer, no. So any other question?
Sir, asa ka nag-cut to sir, sa middle sa steel, di ba?
Sa steel?
Ah, okay.
Oo, ang akong i-consider is ang left side, no. So ang arrow mo na siyang mag-indicate kung asa ako ang i-consider nga side, no, sa ako ang analysis. So if left side, so mo na ni siya iyang free body diagram,
So, sir,
kani
what
siya
if, sir, kung ang arrow na kayo nag-point dito sa left, sir?
sa left.
Sa green, oo, kana sa steel. So, what if kung may
Okay.
point sa left, sir?
Okay, so sige ha, atong i-solve nga, for a while ang atong i-consider is ang left side sa ato ang color yellow na lang, sa steel. So left side sa ato ang cutting plane, then kuon nato ang iyahang stress, no, or internal reaction. So let's see if the same lang ba. So in this case, ako sa screenshot para dali lang ang pag-drawing. So 'di ba ang atong pagkuha sa internal reaction ni steel is inani man siya nga style or ang right side man sa to ang cutting plane. So let's say ang ato ang left side ang atong i-consider. Maigo pa ba for a while ha? Sige, diri na lang. So, ayaw lang i-mind ang cutting plane nga color red and blue, no, since ang atong gikat nga plane is steel. So, kani si color yellow ato ang i-consider. And with that, makita no ang ato ang internal reaction at steel. So, assuming going to the left ang ako ang assumption, no, for steel or PST, no, internal reaction at steel. So, the same with kaning atong analysis kang aluminum, no, nag-take lang ta og summation of forces on x-axis. So summation of forces on x-axis equal to 0. Then sa left side sa ato analysis sa steel, makita ang unsa nga forces. So we have 4,000, 9,000, and si 2,000. So since these are vector quantities, so magmatter na ilahang direction, no? So muna siya kung pasabot nga important nga masabtan si vector and scalar quantities. So for this case, summation of forces on x-axis, so since the internal reaction kang steel, ako siyang i-assume as going to the left, so ako lang siyang iusa with 4,000 since Going to the left man pod ang imuhang 4,000. Then 9,000 plus 2,000. So murag shortcut ta na siya class actually. Kanang left is equal to right, no? If mag-take mo og summation of forces, or um um forces going down is equal to forces going to up. Anyway, so let's have PST. So pila man nato ang PST in this case, or internal reaction at steel. So 9,000 plus 2,000 is 11,000, no? And then transpose 4,000. So 11,000 minus 4,000 is 7,000. 7,000 pounds. So therefore, um, we have 7,000 pounds, no, for internal reaction is steel. And notice that the same lang siya here sa ato ang first consideration, atong right side sa ato ang cutting plane atong i-consider, no? So 7,000 pounds lang gihapon ang iyang internal reaction. So if i-compute mo ang stress, no, or normal stress at steel using this analysis, kaning ikaduha na ang analysis nga left side atong i-consider, then you'll arrive at the same answer lang yapon, no? So normal stress is equal to 4,375 psi. Okay ba? Nasabtan ba? Or any questions?
Sir, kanang pag-solve na mo, sir, kami na mag-vote on sa na mo pag-analyze, sir. Within
Yes.
team, kami lang. Sige, sige. Thank you, sir.
Oo. Depende na siya sa inyo ano kung asa mo convenient, no, or as you practice in yung problem solving, maka-come up man gid mo og inyong own convention, no, or inyong own style. So it's just that the concept mo gid ni siya, no. It's just i-follow lang gid ang concept and ang iyang principles sa analysis para dili pud mo masayop. So ana lang siya. Sige, so proceed ta with our second example. So sa sample problem number 2, ako na lang siyang i-copy, di na lang ko mabalik sa to ang PowerPoint para dili na mag-consume og time. Okay, so for situation, sample problem number 2, a homogeneous 800 kilogram bar AB is supported at either end by a cable as shown. So compute the area of each cable if the stress is not to exceed 90 MPa and in bronze and 120 megapascal in steel. So you are given limits, no, of stress, no, or iyahang maximum capacity nga stress. So for steel, 120 megapascal, and for bronze you have 90 megapascal. Then you are asked to determine the area, no, so compute the area of each cable if the stress is not to exceed those limits nga gi-provide. So area ato ang pangitaon. So first, ato sa i-draw ang iyahang free body diagram. So in this case, you have bar AB and si supports, no? Yang gi-carry. So kanang reaction, no, at point A and B, muna siya ato ang internal reactions kang bronze o kang steel. So ato lang i-label no si point A and si B. So how do we find the reactions, no, or the internal reactions, no, at supports? So actually mura lang ni siya og simply supported beam class, no, kay supported man siya at both ends. And nag-mention siya ang problem that the mass no of your bar is 800 kilogram. So it since it is homogeneous, it is just acting on the centroid no of your bar. Ang iyahang mass which is 800 kilogram. So if we'll take the weight of this bar, so it is 800 times 9.81. Therefore, the weight of the bar is 800 times 9.81, 7,848 newtons, no? Okay. Now, unsaan man to ni pag-determine si internal reaction at ano siya diri, bronze, PBR, and the reaction at steel or at point B. So again, mura lang siya og simply supported na beam. So when we say simply supported na beam and naa siya'y concentrated load P ano, at the center of the beam. So ang shortcut ana, since it is ano lang man no, symmetrical ang iyahang figure and ang iyahang loading, so pwede na to or safe lang na to i-assume that the reaction no, at point A, let's say this is point A and point B. Point A is just one half of P, and the reaction also of point B is one half of P. So in this case, PBR and PST is just equal, no? Which is one half of W. So 7,848 divided by 2 is 3,924 Newton. Excuse me. And also, si reaction no, at steel is equal to 3,924 Newton. Okay, so now nakita na nato ang iyahang reactions no kang bronze o kang steel. So makompute na nato dayon ang iyahang areas no. Ako i-label dere. For bronze, so unahan nato compute kang bronze. The stress limit for bronze is equal to 90 MPa. And the force na na-apply kang bronze no is pila to siya 3,924 Newton. Ang ihalang reaction no. And you are asked to determine if how much ang iyahang required nga area no, para makarry na siya nga load. So, a formula for stress, uh, P over A. So you have the stress and the internal load or the load applied, then makompute niyo ang imuhang area no for bronze. So in this case, you have 90 MPa. So ako lang i-show no ang iyahang units kay para makita nato ang iyahang pag-cancel and if unsay mabilin nga mga units no. So stress is 90 MPa. So that is 90 times 10 to the power of 6 Newton per meter squared or ako siyang gi-convert no into its basic nga unit sa force or sa stress nga Pascal, no? So, since naka-megapascal man siya, so ako siyang gi-multiply og times 10 to the power of 6, then naka-pascal na siya, no? Then ako lang gi-breakdown si Pascal into Newton per meter squared. Then, applied load, you have 3,924. So, 3,924 Newton. So, makatabang na siya class kana bitong pag mag-solve ka, include nimo og sulat ang ilahang units kay para dili ka masayop no sa imong calculation. Divide by the cross-sectional area which is mao ang gipangita. So of course, since naka-Newton per meter squared man ang ato ang ano no, stress, so ang ato pong applied load dapat naka-Newton pod siya. So dili ka mogamit og kilonewton no. So masayop ka ana if 3.9 kN ang imong ibutang dire sa imong calculation. So anyway, area is now equal to pila man ni siya. So 90 times 10 to the power of 6. I mean 3,924 divided by 90 times 10 to the power of 6. So you have 4.36 times 10 to the power of negative 5. So unit for this, so makancel ang Newton. Ang labilin is meter squared. So this is in terms of square meter na area no, but if ato siyang express in millimeters, then ato lang siyang i-convert. So in 1 meter, you have 1,000 millimeters. Yan lang ko isulat ang mm. Therefore, you have an area equal to 43.6 millimeter squared. Okay? So, muna ni siya ato ang area no for steel. Wala na ako siya na label. Ay, sorry, no, for bronze rather. 43.5 millimeter square. Since wala man gi-indicate sa problem no if as to what unit nimo express ang area. So technically correct ra gyapon na imong area nga naka square meter no. But as koan traditional approach or conventional approach in solving this kind of problem, express nato siya no in terms of millimeters. So let's have the steel. Let's solve for the steel. For steel. The limit no or the stress limit for steel is equal to pila ito siya 120 MPa. And the applied load for steel is equal to 3,924 also no 3924 Newton. So let's compute the area no required for steel. So stress is equal to P over A. 120 times 10 to the power of 6 Pascal or Newton per meter squared is equal now to um, 3,924 Newton divided by the cross-sectional area for steel. So solving for the area of steel, you have 3,924 Newton divided by 120 times 10 to the power of 6. You got 3.27 times 10 to the power of negative 5 meter squared. Convert lang po nato siya in terms of millimeter. So you'll have an area equal now to area for steel, 37.2. No? I mean, 32 rather, no, sorry. 32.7 millimeter squared. So that's it. No? Na-compute na to ato ang areas no at each cable para ma-carry niya ang 800 kilogram nga bar AB nga dili mag-exceed sa iyang stress capacity.
Excuse me, sir. Pwede ba pa-screenshot dito sa steel, sir?
Okay.
Thank you.
Okay. Okay.
Thank you, sir.
Okay. Sige, so proceed ta with our sample problem number 3. Okay. So for a while, I'll give you time na lang muna for to copy the problem no and ang figure. Mag-inom sa ko water class for a while. Ha?
Sir, pwede i-zoom lang gamay,
Okay.
sir. Thank you.
Is
Ako na lang sa transfer no para makita ko ang figure. Kaya ilang klase ako sa kong tubig. Okay. So, for a while, ako nabasa dali sa ano, chat box. Kaganina ba ni nga questions, no? From Kim Harold o Ganjobi katong 2000, I think na address naman nino kaning, sir, what if left side ang gamiton? So,
Pwede
first,
lang na sir check.
okay. Sabi na ako. Anyway, so for sample problem number 3, the block of weight W hangs from the pin at A. So, si pin A. The bars A, B, and AC are pinned to the support at B and C. So, the areas are 800 millimeters squared for AB and 400 millimeters squared no for bar AC. So, gitagaan to cross-sectional areas no for the two bars. So, neglecting the weights of the bar, determine the maximum safe value of W if the stress in AB is limited to 110 megapascal and that in AC to 120 megapascal. So again, gitagaan niya mong taog stress limits, no? For AB is uh, 110 MPa and for AC 120 MPa. And you are asked to determine the maximum safe value of W. So safe value of W ang atong pangitaon na ni, no? Given the parameters na giset sa problem. So first, mag-draw lang yapon ta ani og free body diagram. W and the internal reactions no at AB and AC. So PAB and PAC. Okay. So now, sa amin ni pag solve. So gamitan na nato ato ang knowledge no on concurrent force system no and sa to ang statics. So mag-take ta og summation of forces on x and y axis no para maka-generate ta og equations. So summation of forces on x-axis equal to 0. So what are the x components no of forces nga involved? So CAB and CAC no or PAB and CPAC. So they have x components. And since oppositely directed nila ang x components no, so pwede na ako ni siyang i-equate. So PAB cosine 40 is equal to PAC cosine 60. And then for summation of forces on y-axis equal to 0. So what are the forces involved? So you have W going down, no? So pwede rin natin na siya i-take as forces going down is equal to forces going up. So W is equal to PAB sine 40 plus PAC sine 60. Okay, so now let's try to express AB or AC no in terms of the other para maka taog other equations as well. So let's say Rowan. Ako lang color-coloran no. So let's express AB or PAB or PAC na lang siguro is equal to so i-divide lang nimo ang both sides sa equation no by cosine 60. So you will have cosine 40 divided by cosine 60 of PAB. Ito rin na lang natin butang. So, pila man ni siya? Simplify ta ni siya, no? Cosine 40 divided by cosine 60. You have 1 point, excuse me, PAC is equal to 1.532 of PAB. So, ato lang po na siyang i-substitute sa ato ang equation nga na-generate from submission of forces y-axis, no? So, W is equal to PAB sine 40 plus PAC, which is 1.532 of PAB sine 60, no? Excuse me. So, combine like terms lang, no? Simplify lang din nato. We will have W is equal to, pila man na siya, sine 40 plus, okay, tama, no? Then ay nag-answer, ay nag-calculate po, 1.532 sine 60. 1.9 7 na lang, no? 97 of PAB. So, if i-express na to si PAB, no, in terms of the W, then we'll have PAB is equal to, so divide both side lang, no, by 1.97. So, that is, ang pag-abot ka W is W divided by 1.97 or 1 over 1.97. So, you will have 0.508 W. So nakakuha na taog relationship no between the internal force at AB and the W or the weight. And we will use this para makakuha po taog relationship with W or the weight and the internal force at AC, no, or at bar AC. And that is just PAC is equal to 1.532 of PAB, and PAB is 0.508 of W. Therefore, PAC in terms of W is 0.778, no? So PAC in terms of W is 0.778 W. Okay. So now, nanatay equations, no? And relationships, no, ba with with respect to weight and our internal forces at AB and bar AC. So let's solve for W, no? And let's try to determine if what value is say the safe maximum value for W. So so to siya first, si AB, sige. For AB, you have stress limit for AB equal now to pila to siya ha? 110 megapascal. And the cross-sectional area for AB is given to be 800 millimeters squared. And we also have the applied load or the force, internal force at AB equal to AB 0.508 of W, no? So by this, makompute na to ang W, no? Using the formula nga provided by the stress, which is stress is equal to P over A. So you have 110 MPa. So times 10 to the power of 6 newtons per meter squared is equal now to PAB 0.508 W divided by the cross-sectional area of bar AB 800 millimeters squared. So 800 squared. So take note that ang ato ang stress no is in terms of newton per meter squared. So meaning dapat ang ato pong area nga gabiton is in terms of meter squared, no, since dili sila compatible, no, or dili sila mag-cause og error sa imong calculation if ang imong gamiton is millimeter squared tapos naka pascal ang imong stress. So you have 800 squared. So i-convert na to siya into meter squared. Or what? 1,000 millimeters. Diba? So times 1,000, I mean 1 over 1,000 millimeters squared, no? Therefore, you will have the value of your W. So, mag-cancel na siya, meter squared, no? And may mo na siya meter squared ang mabilin. Mag-cancel out ang meter squared. So, mabilin sa to ang unit is Newton na lang, no? So, W or weight for bar AB, maximum capacity of bar AB nga weight is found to be 110 times 10 to the power of 6 is equal to 0.508 W divided by 800 times 1 over 1,000 squared. Okay, so W is equal to 173,228.347, no? Newton. Or you can express this in terms of kilonewton. So 173.2 kN. So that's the maximum capacity no nga ma-carry ni bar AB. So now, let's solve for bar AC. Yang stress limit is 120 MPa. On 20 MPa. And ang ihang cross-sectional area for your bar AC is 400 millimeters squared. Or well, murag na ako'y nabantayan. Okay, so that is 400 millimeters squared, no? And the applied load or the internal force at AC is equal to 0.778 W. So same process, let us solve for the area, not area rather, no, but WDI using the formula for stress. So stress is equal to P over A. And you have the stress limit for AC, 120 MPa times 10 to the power of 6 Newton per meter squared equal now to 0.778 W divided by the cross-sectional area, which is 400 millimeter squared. So, convert na to siya into meter squared. W now would be so weight is equal to 61,000 rather 61,696.66 Newton or 61.7 kN. So, mo po ni siya ang maximum weight nga ma-carry ni bar AC no without exceeding the stress nga gihatag sa iya no, or limit na stress niya. But dili pa ni siya mao ang final answer no. Ang final answer ani is ang ato ang conclusion. So therefore, the safe value of W is equal to, so pila man. So actually ako tani siyang ikuan na nga nga ano no, nga part nato ato ang mentimeter bitaw no. Ako ta siya mura is somewhat survey nga letter A si 173.2 or letter B, si 61.7. So what do you think? Ang safe value nga atong i-declare no for our weight.
61.7, sir.
Okay, so tama no. So it's letter B. No, it's actually 61 point for a while. 1.7 kilonewton. So the idea class is that ang for bar AC 61.7 kilonewton lang ang iyang maximum capacity no nga ma-carry no nga weight. And for bar AB ana siya ang iyang maximum capacity nga weight nga ma-carry is 173.2. So if ang atong i-declare nga safe value for or maximum value of weight for W is equal to 173.2, dili na makarry ni AC, no? So kung magbutang ka og load or if ang load nimo kang W is equal to or greater than 61.7, let's say 80 kilonewton, so mag-fail no si ang bar AC. So dili na niya kaya i-support. Whereas if atong i-declare is ang maximum value for W is ang kani si 61.7, so makaya pa ni bar AC. So dili pa siya mag-fail, no? Wala pa failure mahitabo. Then for bar AB, so walay problema kay ang declaration man or ato mang nakita no sa tong computation that for bar AB kaya niya mo support up to 173.2 kilonewton nga weight. So meaning pansit ra kay sa iya ang 61.7 kilonewton nga weight no. So if atong take as the safe value or maximum value of W for this system ang 61.7 kilonewton, then our system would be safe lang no and efficient. So inana lang siya class. So if you are asked to determine the allowable stress or maximum allowable stress, maximum allowable weight, maximum allowable load, then always choose the ano no pinaka least kay para safe ang imuhang structure. Okay, so any questions or clarifications
Pwede na case is, sir. Is atong pa.
sa first solution or
Hindi lang,
first
sir.
part?
Yun lang.
Okay. So
Excuse me, sir. Kanang mag-provide gyapon ka ani sa USTEP, sir? Kaning lecture material, sir.
yes, to ako na siyang i-upload yapon sa atong U-Step. Actually, nag-upload ko earlier or kaganina before sa to ang class. I-upload na ako atong lecture material for dynamics kagahapon. So, if you'd like to access it, naarap po siya sa to ang U-Step.
Okay, sir.
Mm-mm. So, I'm not just sure if ang both ba nga PDF ang na-upload kay I think
Isa ra, sir.
lagi. So, mo po na ako ang
Naka-whiteboard.
na lagi na. Mo po na ako na discover earlier no pag-upload na ako then ako siyang gitry og access isa lang ang makita. So, kuan siguro yun no isa-isahon gid siya or individual gid nga file ang pag-upload siguro sa UStep. So naanad ko sa Google Classroom nga under week 2 nga lecture material so naa na dito tanan nato materials no nga necessary for week 2 nga lecture nato. So nandito ato ang solution, ato ang lecture material and if natay other sources nga akong i-provide sa inyo. So, dito na po na ko siya i-attach. So, sa UStep, I think individual, gid siguro siya nga i-upload. So, sige lang, ako pa nang i-discover no if pwede ra ba nga in one file, then duha na ka for a file ang akong ma-upload. So, katupong last week, sa week 1, ay pa po na ako na-discover nga isa ra pod ang makita ninyo no or ang ma-view. Kaya ako po siyang gitry og access or gitry na ko siyang download. But actually duha to ka file akong i-upload katong PowerPoint og ang core syllabus. So anyways, mag-create na lang gyud siguro ta ani o Google Classroom no for lecture materials kay para dili ra pod libog sa inyong mga part pa di ra kayo daghan bitaw i-download pag tuplok ninyo sa week 2 or week 1 nga material then naa na dito ang inyong kailangan nga files. So any questions or clarifications?
Murag none so far pa, sir.
Okay, so if wala nang may question clarifications no regarding sa atong discussion, mag-attendance sa ta before ta mo i-dismiss. So just say present no if you are here, then if not, I mean if dili ga function imong microphone, then you can just click the raise hand button para ma-acknowledge yun yung attendance. So Aberin Monique,
Present, sir.
Abrenica Hannah,
Present, sir.
Asibar Maria Christine,
Present, sir.
Akonga Lloyd Vincent,
Present, sir.
Pastatas Joby,
Present, sir.
Bayotas
Liguan mo
Monique,
si Blue karon kay.
Present, sir.
Ako na magligo
Benida
kay Blue.
Janille Rose,
Present, sir.
Bonglay Joby,
Present, sir.
Kailing Joby,
Present, sir.
Biharme Paul Joshua,
Present, sir.
Ekonar Donby, Leoren Jeffrey James,
Present, sir.
Malagamba Christian Clint,
Present, sir.
Medallia Rosel,
Present, sir.
Meriales Joyce, Mugot Ryan Van,
Present, sir.
okay, naa si Meriales di ay. Nahia Lendy,
Present, sir.
Esperos Paul Vance,
Present, sir.
Oclarit Eliza Nicole,
Present, sir.
Ortez Lord Vincent,
Present, sir.
Akana German Martin,
Present, sir.
Perihan Jezreel Vincent,
Present, sir.
Udadera Kiro Clemens,
Present, sir.
Sakwan Arlegin, Saging Jason,
Present, sir.
Kaniko Starian,
Present, sir.
Sharif Muhammad Ali,
Present, sir.
Sultan Rodelin,
Present,
Tabuelog,
sir.
okay, Tabuelog Dance Lester,
Present, sir.
Takandong Justin Bryle,
Present, sir.
Tadlas Mary Bell, Ambis Jomar,
Present, sir.
Taob Mary Josephine,
Present, sir.
Texon Maureen,
Present, sir.
Chu Cortreras, Kirby,
Present, sir.
Toquero Lovelin, Valdueza Shane Can,
Present po.
Villanueva Ren,
Present, sir.
Ibanez Kim Harold,
Present, sir.
Zacharias Prince Edward.
Present, sir.
So if wala na mo laing concerns and clarifications, thank you for your participation today. Good morning and class dismissed.
Thank you, sir.
Thank you,
Thank
sir.
you, sir. Good morning,
Thank you,
sir.
sir.
Thank you, sir.
Yes,
Thank you, sir.
Maligay,
Thank you,
sir.
sir.
Good one.